Alright guys, so in this video we're going to talk more about conversions, but before I do that I want you to kind of go back and think about what we did in the last video. We did what I call one-steppers. They are one-step conversions, and this is a very simple conversion factor that we're pulling from a table or some kind of resource material that we're using, and typically that one conversion factor or that one step in the dimensional analysis will typically give us the answer that we're after. However, we never at any point in time did something that was more than one stepper, and we can do these, and we can go to 2+ steps. I mean, that doesn't matter. Dimensional analysis still works. We still use the same concept. Nothing really changes if we do this. So let me kind of show you an example of one of these, and we're not even going to use an appendix. We're going to use something generally that we know. So let's say that, for instance, we have a problem, and the problem says, hey, we've got 41.5 hours, and we want to know how many seconds is that? Well, I don't know about you, but I can't really go through in my head and say, well, this is how many seconds there are in an hour, right? I mean, this is something that we can do, but it's going to have to be more than one step. And whenever I get to these types of problems, I'll always like to do them in more than one step anyway. That way I'm not missing or ignoring any important pieces or problems that I'm basically going to run into if I'm not careful. So I'm just going to treat this just like before. I'll take 41.5 hours and I put that over 1. I mean, that was the general dimensional analysis step. And then in the next step, remember, I just started with a division bar and I worried about units. I worry about units first, and then I go back and start filling in numbers. So that's what I'm going to suggest here as well. So hours up on top and hours go on bottom. And can I go to hours to seconds directly? Probably not, right? But I know how many minutes are in an hour, so why can't I do that? And I can. But that's not where the problem wants me to be. The problem wants me to be in terms of seconds. So I need to bring in another conversion factor, and that's fine. You can bring in as many as you want. So up here at the top, we have minute. So that means in this next step, minute is going to go to the bottom, and here I can relate seconds and minutes together. That one's pretty easy for me to kind of go back into my brain filing cabinet and pull out. So it looks like this is a two-stepper, and that's perfectly fine, but what you're seeing is that we haven't really changed anything, right? The general template is still up there. So now I go back and start filling in my numbers. Well, minutes and hours, what's the relationship here? Well, there's 60 minutes per 1 hour, right? All right, so there's hour, there's going to be a 1 in front. In 1 hour, there's 60 minutes. So that's where those values are going to go. And then here in the next step, seconds and minutes. Well, I know that one too. There's 60 seconds in 1 minute. So that is a conversion factor that I'm going to bring into the dimensional analysis problem. So here we have minute. In 1 minute, because that's what a conversion factor says, there's 60 seconds. All right, so it looks like that's going to be the setup for the dimensional analysis problem, and it looks like this is going to be a straightforward multiplication, right? I'll take 41.5, and then I'll multiply by 60, and then I'll multiply again by 60. Remember, I ignore the ones. I don't even pay attention to them. If you divide by 1 in each one of these cases, it's not going to change the number, right? Or if you multiply by 1, it's not going to change the number. So I'm going to bring in the calculator just so you can see this get entered on the screen. And this can be just a straightforward multiplication, 41.5, and then we're going to multiply by 60, and then we're going to multiply by 60 again, and we're going to get 149,400. All right, so 149,400 seconds is going to be the answer to that problem. Now, significant figures are also going to be a thing here. We want to watch out for significant figures whenever we can, and it looks like this value here is 41.5 hours. So if we did this with significant figures, like we did in previous videos, I need to make sure that I have 3 significant figures here. And my 3 significant figures would actually stop right here. So I need to figure out, will that round up or not? And the answer is no, it's not going to round up. So this looks like it would round to 149,000 seconds. Now, the problem here that we didn't talk about in the significant figure world is that sometimes conversion factors are exact. Right? And exact means you do not include the values that you are using in the conversion factors as significant figure barriers. So I'm not going to look at that 60 and say, well, you know, that 60 is one sig fig the way that it's written, so my answer should be 1. No, that's why we always go to the front end. We always go to the actual value that's given in the problem, and that will determine the number of significant figures at the final answer of the problem. Never look at conversion factors for significant figure rules. These are what we call exact, meaning that I can actually go in here and say, well, if we've got 1.000000 hours, then that's going to be 60.000000 minutes, and I can make these have as many decimal places as I want them to have. It doesn't matter because they're exact, and that is not going to play a factor in the sig fig world as far as determining how many is going to be in my answer. All right? Okay, so in this video, we now want to go another step further, and that's really to focus on the metric units. And I'm going to first talk about a base unit here. So the base unit is anything without a prefix. There's no prefix in front. What is a prefix? I'll explain that in just a minute if you've never seen those before. But a base unit can be anything. It can be liter, it can be second, it can be gram. It doesn't have a prefix or a word that starts out in the very front. So from the base units, we can actually go bigger and we can actually go smaller, right? And this is where the prefixes come into play. So some of the smaller prefixes that I can use in terms of the base unit would be something like centi, or something like milli. So centigram, milligram, centiliter, milliliter. Those are smaller prefixes, meaning that we're talking about smaller portions of a substance that is going to be in reference to the base unit. And then we can go bigger as well. And one of these common prefixes would be something like kilo. So we can have kilogram or kiloliter. If this base unit was meter, then that's fine. This is centimeter, millimeter, or kilometer, or kilometer, really is what we say most of the time. But this is a prefix that is bigger than that base unit. Now, these are not the only ones that are there. So I want to talk about some of the most commons, but I'm going to put many more on here than what we use most of the time. So I'm going to go back and we're just going to start with base unit again, and we're going to go bigger and we're going to go smaller. So when I go bigger than the base unit, typically what happens here is that the first prefix is going to be deca, and that is a deca with a K. The next one is hecto. The next one is going to be kilo. Then we have something called mega. Then we have something called giga. And then we can take another step and go to tera, but I'm just going to stop there. Now, I did something that I probably wasn't supposed to do. I'm going to erase this first letter up here. I did it with the G and I did it with the M, but I did not do it with the big K or the big H or the big D for deca. All right, so we've got deca, hecto, kilo, mega, giga, and tera, but tera is not written. Notice I try to put a capital letter here, and the reason that I do that is because I kind of want you to think of big letter, which means that unit has gotten bigger. So these are very large amounts of things. You know, a deca liter or a kilo liter or a giga liter. Those prefixes are meant to instill this image that you have quite a bit, a lot. So these are very, very large. That's what those prefixes are for. Okay, the base units we can go smaller. So if we do go smaller, then I like to start these out with little tiny letters in the very front. So instead of deca, D-E-K-A, this is deci, D-E-C-I. The next one is going to be centai, and then we have milli, and then we have micro, and then we have nano, then we have pico, and then if I want to go maybe one more can be femto, but we just rarely ever go that low. All right, so all of these prefixes start with a tiny letter, and these tiny letters mean in my head tiny amounts. So a microliter or a milliliter or a centiliter is a very small amount of volume, basically due to that prefix that's in front. That's where my head space needs to go. All right, so we have a lot of stuff up there at the top, and then here we have a very small amount of stuff here in the very bottom. All right, so we're getting ready to bring in conversion factors, and instead of writing these all over the place every time, the base unit is understood to be 1. All right, so whatever unit that we have, a second, a liter, it doesn't matter. I don't care. But this base unit that doesn't have one of these prefixes on it, that is going to be regarded as the 1 in the conversion factor. So that means that if I want to talk about decis, well, what are decis? Well, one base unit is actually going to end up being equivalent. Decade means 10 years. So these are 10 deci units. Centai is century. That means 100 years. So this will be 100 centais. Milli means a millennia. That's 1,000 years. So that will be 1,000 milli, whatever that I've got. Micro. Well, with the micro units, we're actually going to add on 3 more zeros. So this is actually 1,000,000 here, micro units. That's also abbreviated with a U. Nano. Well, nano is going to add on 3 more. So here is my 6 zeros, and I'm going to add on 3 more, and this is the nano unit. And then if I look at pico unit is going to add on 3 more zeros. So we're going to have 3, 6, 9, and then 3 more, which is going to be a total of 12. And this is pico. The abbreviation for pico will be a P, small p. The abbreviation for nano will be an N, or, well, we're not going to go that way, just an N. Micro is going to be a U. Milli is going to be an M. Centai is going to be a C. And deci is going to be a D. All right, so what this means is that when we start doing these conversion factors, I need to start bringing in conversion factors. And this is going to be a table that's going to give me what those conversion factors are. Meaning that if I need to go from, well, let's say that I had 4 meters. How many centimeters would that be? Well, I'm going to look at this chart that I've just generated, and I'm going to go, oh, meter doesn't have a letter in front. That's my base unit. So my base unit is 1. So that means 1 meter is equal to their centai. Centai means 100. So 100 centimeters. That is the conversion factor that we'll use in that dimensional analysis problem. All right. So deci, centai, milli, micro, nano, pico, and femto. If we want to talk about femto, guess what? It's going to add on another 3. So it goes 12 to 15 zeros. But we just don't really use them that often. In a laboratory environment, we often will use our centai unit, our milli unit, and our micro unit. Those are the 3 that are going to be the most important for us as a whole. But we do talk about these other prefixes. It's just that in a working laboratory, we rarely ever go lower than that micro unit. All right, so 1 base unit is 100 centai units. 1 base unit is 1,000 milli units. And 1 base unit is 1,000,000 micro units. All right. Now, what about if we go above? How do things change, and do things change? And the answer is yeah, a little bit. And these are bigger. And when they go bigger, then we're going to have to change these numbers up a little bit, because that means they're bigger than the base unit. So here, if we go bigger than the base unit, my conversion factor almost has to kind of flip around on me. So what does that even mean? Well, when we go to deca, this deca, again, is going to kind of represent 10, but this is a bigger unit than the base unit. So we need 10 units in order to make one deca unit. And we typically, I like to use a capital D here, even though sometimes you might see people tell you not to do that. I still like to use capital D for the prefix, and that's to let you know that is a bigger unit. So 10 units, if I gather them all up together, is equivalent to one deca unit. Hecto is going to be this idea. Sorry, let me go back, because I do want you to understand that some people do use a lowercase d here as well. And now you see kind of the problem. If you use a lowercase d, then that's going to be confused with the lowercase d for deci unit. So this is another reason that I like to use the capital letter, so that it doesn't interfere with anything. But for those people that do like to use these lowercase letters in front, even with the bigger units, they will typically involve a here as well. So a DA or deca, and the A is the ending A that deca starts with, right? So the capital D, the A at the end, that DA represents deca. So again, that's why I don't really like to use those. I think it confuses you more than anything, and that's why I like to use the capital D, even though capital D can also mean something else in the laboratory world. Hecto, for the same reason, I like to use a capital H here. Again, that capital H could be maybe something totally different, and some people might stray you away from that, but I like to use the big letter to make you think big prefix, especially in the beginning. And this is another step up, and that means 100 units. So 100 units will equal one hecto unit, and whatever that unit is, I don't really care. Kilo is going to come next. Kilo is going to be 1,000. So if I take these base units and I gather up 1,000 of them at one time and put them in a big old pile, then I'm going to have a kilo unit. And here I don't really use a capital letter, and that's because kilo is so common and we see it all the time that I think that you will become very comfortable using a lowercase k in these instances. And therefore, I don't even talk about a capital letter here because I will rarely use it at all. Next up is mega. So this mega is going to be a capital M, and even the naysayers will use capital M's for mega as well. And mega is just going to add 3 more zeros onto this number. So this is going to be 1,000,000 units will equal 1 mega unit. And then finally for giga, same deal. You're going to have a capital G for the letter, and that's going to be another 3 zeros on it. So instead of 3 and 6, we're going to have a total of 9. So 1 times 10 to the 9th units is equal a giga unit. All right. Okay, so those are all of our conversion factors that go above the base unit. So again, literally what I mean here is that if I had a mega penny pile, then that means I've got pennies, that's my base unit, and I've got mega of them, 1 mega penny pile, right? So that means I'm going to have 1,000,000 pennies in that pile if I count them individually, one after another after another. However, if I have a millipenny, then that means I've taken a penny and I've actually used a pair of scissors and I've cut it up into 1,000 little tinier pieces, because that's what milli means. and I'm talking and I'm referring about one of those little bitty tiny pieces that we call a millipenny. The same way with a cat. If you know a crazy cat lady, then the prefixes still happen just as fine. So the crazy cat lady that has kilo cats, well, you go to her house and she's going to have cat, which is the base unit, and she's got a kilo unit of them, which means she has a total of 1,000 cats in her house. So imagine how that will smell. However, if that crazy little old lady decides to go smaller and she wants a micro cat, then she's going to take a cat and she's going to take it into her kitchen, and she's going to take a knife and she's going to chop it up into 1,000,000 pieces, and she's going to talk about one of those 1,000,000 pieces, and that is a micro cat. So the things below are smaller portions and the things above are larger portions. So this is our concept of metric to metric conversions. We now know some of the abbreviations, we know some of the prefixes and what they represent. So in the next video, we're going to do some problems, and we're going to refer to this chart that you just wrote down, I hope, on a sheet of paper, because we'll be using this over and over and over quite a bit. All right. So that's what we'll do in the next video. Come back, see me. We'll talk about some more math. We'll talk about some more conversions, and then that will finish up our conversion, small, tiny, little bitty lecture.